Yeah. So welcome everybody after lunch from my side as well. So to keep you awake, so we activated the flicker here so that you stay awake. Okay. So the talk today is it's more about our open source integration. So I'm from SAS. So we have of course, I will explain a little bit about our software, but it's more about our open source integration today and basically about the model lifecycle management integration of open source models. In this case, it's scikit-learn Python models. So that's the connection point to Python. We'll find others. Here on the slide, you will see the name of my colleague, Tamara Fischer, who couldn't make it to the conference today, so that we prepared it together, and I try my best to cover her part of the presentation. Presentation itself, it's structured in 4 parts. The first part is simply giving an idea who SAS is, as short and meaningful as possible. Yeah, and then explain what we really mean with the model lifecycle management with SAS. And I think probably for this conference here, the most interesting part is to see how you can use Python and the REST paradigm to model lifecycle, a scikit-learn model, analytical model. And in the last part, we will give you an idea to use another component using standardized workflow engine to further standardize the model lifecycle management process. So let's start with a little bit of marketing, just because we had some talks, and yeah, it's Python, and for a long time SAS didn't use Python as coding language. We have our own, so only a few people know about us, so that we take the opportunity to just say a few words. So since 42 years now, we're essentially developing and selling analytical software. And that's basically it. And what we very much focus on, we use, of course, the software ourselves in client projects. And where we focus on is on the extraction of value from the data, business value for our customers from their business data. That's very simple. 2 points I would like to mention here is, first of all, about data. We do not provide or sell our own persistence layer like a database warehouse. We have own internal highly parallelized distribution persistence layer, but we don't sell it. So for 40 years, we had to connect to different data sources, and we have a very vivid and great ecosystem of connectors. So that's very important for us. On the other hand side, what does producing value means? It does not only mean producing a nice and fancy model and explaining it. It's very important for us to bring that into production, to different production systems. Could be an event stream, it could be a simple server, to model lifecycle it. That's what we want to talk about today. It's mainly the quality assurance of a model in production. And of course, we have presentation layers for our customers to visualize the results and to take it in everyday life. So yes, we have a lot of analytics. Don't want to go into detail here. It starts from classical statistics, text analytics, data mining, forecasting, up to all the buzzwords like cognitive computing, deep learning, AI, and machine learning. Everything is a platform. I think what's really important for us is, what's so simple here on the slides is what we call the analytical lifecycle. And I guess that's something everybody's doing here. So it's basically the integration of people and processes in different roles to deduce the value from the data. So usually consisting of different roles which gather the data, so it might be an analyst, a business analyst, a data integration specialist, bringing the data together to a first analytical base table, where probably the data scientists and other people and other roles start building analytical models, a machine failure model, a churn model, a risk or credit defaulting model, whatever you like. And what we experience is that in the market, really 80% of all the proof of concept miss the third part. They are not thinking about how do I bring what I produced, the nice and fancy results, how do I bring them into production? So that, and that's very often also in projects, not only in proof of concept. So that means, where do I publish my model? Could be, as I said, could be simple things like a serialized pickle object or a web service, but it could be an event stream you can't shut off, and you have to inject in real time your model or a parallelized database system. So That's one thing. You have to keep track of the quality of your model. So the model's ages in production, so you have to keep track of that. And as I said, you have to have a presentation layer for the results. So these are things, and the deployment part is my focus of today, where I want to show you the integration using Python and REST. So there, of course, the life cycle is also the motivation for our complete platform. I will drop today, no fear. So, but it has some nice things. First of all, we of course have the full cooperation of all the roles with all the rights and authorizations. So we are a full failover enterprise environment. Everything which we have is fully distributed parallelizable, so multi-threaded and distributed. So when you need more compute power, just put another blade to the side and go from there. But I think what's most important for today is the last part, the diversity. Of course, we learned in the last years that you have to have an API like Google and others to your core to make it available to other coding paradigms like R, Python, Lua, Java. So that's where, and of course, the REST paradigm. So that's what we want to talk about today. And so let's start with the basics, the model lifecycle management. So what is model lifecycle management essentially? So the idea is if you have an analytical model and you really put it into production, your process changes because you improve your process, you probably optimize it. Doesn't matter which process it is. That changes your data because your process changes. And so your model definitively after some time will not reflect the data and the process correctly. And you have to quality ensure over time and to find out that your model is degrading. So that's something most people don't like to do because to be very honest, it's simply boring. Yeah, it's simply boring, but it's the most important stuff to do for the industry, for your customer. Most of what we experience, most of our customers don't really understand the analytical models. So the business value is lying in putting into production and lifecycle of the model. So, and this is a blueprint here, which you see on the slide here. It could be much more complex and our software support that, but the basic idea is twofold. On the left-hand side, you see we manage all the models we have, so it could be a Python, an R, an E, or a SAS model, and that's basically done because we have a central repository. Everything goes in and is versioned, and from there on we can lifecycle models. And on the right side, you see the deployment part, where you put models into production and learn about their performance degradation over time. So, and I will a little bit explain these few steps because we will see them later on in the coding or the snippets. So what you usually do is, if you want to do more lifecycle management, as I said, could be a Python pickle object or an R object or a SAS program. The first thing you have to do is you have to import it into our repository because from there our model is driving everything, our software, sorry. And this next thing is what really very often happens is that you either have one person developing different models and or you have for more critical applications, you have several people going different modeling ways and building models. So you simply have to find out if they register to the repository, what's the best model. That's a model comparison, so the champion-challenger comparison. And what also very often happens that people in a very isolated fashion develop models. So it's a different computer, it's probably sampled, it probably has other namings of the predictors and variables which go into the model. So you have to, in the next step, you have to quality ensure that your model code will really run on the production system. That's what we usually also support in the software. So all these very boring steps, essentially, but important steps. And then if the model, you know that it's working in production, just publish it. So in publishing could be a multitude of things. As I said, today it's just a serialized pickle object. Very easy, you can copy it from A to B. But we also have situations in which you have to publish a model to a Hadoop cluster or to a parallelized Teradata system or to an event stream or in a memory machine. So lots of different options. That's what we support. And then, of course, when the model is in production, you get information about what was the prediction of the model and what was the actual values. So who really churned his contract or who really defaulted, who really defaulted. So, once you have all this information, you usually do model monitoring. So you compare actuals versus the prediction and then can see how the model degrades over time. And from there you have automatic retraining and re-registering, and it closes the loop. So that's basically model lifecycle management. And why are you doing that? Basically in order to have a company which is informed, which knows when, where, which model is in production, and which model you're making decisions. Yeah, who put a model, who signed off a model for production, for instance, for credit risk models. And the second is, if you have a compliant way of handling model management, it makes the regulator happy. We very often see that the regulator is happy if he sees that we are doing model management in a very detailed and event-tracked way. So, and of course, such a tool, and these are the two topics we want to go through further, has some requirements. So first of all, it should strongly support and automate all this process. So that's what we're basically doing with graphical user interfaces and the API we offer. It should support the collaboration. We saw the different people involved in the life cycle. If you should standardize the whole process, that's what we do in the last part by using predefined business process workflows. And of course, if we additionally do event tracking, so you have full governance and compliance, that's also important. As I said, make the regulator happy. And the last thing is, we know that not everybody is coding SAS. Especially in this conference, we learned quite a few program SAS. So it's a Python conference. I'm not astonished by that. But we have to handle the model zoo of different programming paradigms and modeling languages, programming languages for model lifecycle management. So the basic idea is how we start the model lifecycle management is have a central repository. It's very easy if you take the SAS producing software here, so which is producing analytical models. We have a native API to our software and to our repository and can handle the repository management from there. For all the other languages, we also have native APIs, so you could talk Python to our core or R, but we are seeking here for a more general frame to do the model lifecycle management and registering. That's the basic motivation why we use for all the other languages the REST paradigm to do the work here, the model lifecycle management. Just a quick question about REST. I think everybody, I'm probably the worst person knowing REST in the room. REST is known for everybody in the room. I think so. No hands up. But just an idea. So I guess you're shy and nobody wants to say I don't know it, or everybody said it's typical for Python, so I accept that. But just 2 words about representational state transfer. It's essentially you're giving a representational state, so a unified resource locator coming from an Internet Explorer or a web browser or a GUI or a Python programming environment. You talk to your application via the RESTful web service, which essentially parses a string and manipulates objects in your application. So I guess everybody could have explained that much better than me. And that's what we essentially use. So this paradigm, the message is going here over the URLs, basically, so in which you code the protocol, which server you are talking to, and then you have the API, which is basically the main functionality you are offering and talking to. And in the path and in the parameters, you further dive down into your functionality of the application. So I'm here, this is a call to our model manager to software, so where I'm talking to the repository, to the models, to a certain model with a certain ID, this cryptic string over there. So the variables, and finally I modify a variable named on conflict and set it to update. And of course, this paradigm has some request types. You essentially can delete and update and create objects and ask for information about objects. And I think the basic idea then is for data exchange, you have a body, and you have the header information, which essentially allows you to define what's the structure of the body you're sending to your application. You're getting back, of course, and some authority mechanisms. So that's in a nutshell the rest for probably the one person here in the room which doesn't know it. And of course, we have a very rich documentation of our REST API. So we're basically offering 3 APIs. So the repository management, the publish management, and the general model management, and lots of other functionalities. As I said at the end of the presentation, you get some references for the documentation, of course. So let's now go into the lifecycle management, the automation. So what we already talked about. So we want to see how we register models. We find out the best model, put it in production, generate data, do the performance management, and then retrain automatically. The first thing is we have to discuss or have a look at how does the model structure look like. So what are the files we need for the model? So it's basically, of course, we need the Python training, the Python score code, and the ready model, which is serialized using Pickle object serialization. So these are the 3 ingredients which we want to register. And then there are some more. Some of them are optional, others are for quality assurance. So you can, for instance, say what are default training, scoring, and retraining data sets. So if I don't, in my application, if I don't say anything, these data sets will be used for retraining. It's like a default. It's only optional. You don't have to use it. And you have the same information also on the next higher level in our object space, which would be a project. A project is just a handle for different models to a certain business task. Your model, a machine failure or whatever. So where you have different models in different versions. So there you could have this data sets as well. And if you have nothing at runtime, of course, you can specify your training, scoring, and retraining data. And there are some information. So all these are JSON files, as you can see, which gives quality assurance for the execution, for the scoring test, basically saying which are the input and output variables, their scaling and their names, which must go into the model to work properly and which must go out to work properly. And then there are some information about the model. Most of them are optional, but some of them are important, like what is the target variable of your type. So is it the classification model or is it a regression model? Because from there you trigger different charts we will see later on. So that's basically it. That's the model type we put into a zip file in another code segment, and then we start with the rest calls here from Python. So as you can see here, we are basically posting. That's the central. We do a post. So we create an object. That's our model management service. That's our model management service, which is essentially the protocol and the domain I'm talking to. And then I'm having here the repository, the model repository. That's my API I'm talking to. And then I have several parameters. So I have a model which gets a name. So the name has been defined here by a random number. It's tree something between 1 and 10. I define the type of information which goes over the body or the import type into the repository. And the easiest one here is the zip code or zip file. I have the project ID. As I said, that's the handle where I want to register to. I could register different models to this project ID. And I got the idea when creating the project. I automatically get the ID. And of course, that was a REST call as well. So that's basically it. And then we have to give some body information. This is basically that we are saying over the body we have this, we give this zip file we zipped before in the code. It's a multi-part form data. And when we receive it, it's called model name. So that's the name we gave it, .zip. And when the run comes back, we have a complex JSON structure with all the resulting information, which we dive into and can figure out that that's down here. It's the ID of this model I registered. So from there on, I have a handle for this object at any time, and it has a fancy name that a human can remember it. So it's tree8 in this case. The good thing here is if you register to the repository, the graphical user in front end immediately picks it up. So we have customers who model lifecycle manage a few hundreds to a few thousand models. So that's nothing you would like to do with the graphical user interface. Drives you crazy. But it's nice if you can quality control everything you did in the graphical user front end. So in this case, we see that we registered create to the model, to the project, which is called Python Project 3, and it's in version 1. So it's because we never retrained it, it's the initial load. So the next thing is then, we did, of course, the same for the extreme boosting model. The first one was a decision tree, and both were from scikit-learn, so both scikit-learn models. We now would like to know which one is the better one. So we are doing a model comparison. Again, very simple structure. We create a report object. We talk to the model management API. We create a report object, and over the body of the call, we give simply the list of the model IDs. Yeah. So these two IDs I, of course, generated before. I showed you one ID generation. And that's basically doing the performance comparison. So of these both. And again, I then can go to the, I can grab and go on and pass all the JSON information which is coming back, but now it's more fancy to show you the graphical user interface. So essentially you see I registered two models, Create, XGBoost 6, have different metadata like when it was produced, what type of model it is. So there could be something like it's an R model or it's a SAS model, fully mixed. It's telling what are the input variables. Not all models are using the same input variables. That's a decision which has been taken during the training step of the models. And of course, it's showing the performance metrics. So in this case, I took the cumulative lift, and the brown curve is essentially showing you the optimal lift you can achieve from seeing the training data, and the green petrol curve is the model performance. And you simply see you could also fully automate that, but from a visual inspection, you see here that the XGBoost has a much better lift on the first percentile. So that's your friend you want to go with. So, as I said, usually now the publishing into the operational system could be much complex. So on the SAS side, it's mostly just pushing the button. Doesn't matter where we are pushing to, whether it's a parallelized data warehouse or whether it's an event stream. I'm not allowed to shut down. So in real time. But in this case, it's much easier. Since it's Pickle, I just would copy it to my execution system and then have a little bit of Python code. I regular trigger. That's a very trivial one. So it's essentially loading in the first step. It's loading here the Pickle object, and so which you set where it should go when you publish. It could be made also a little bit more advanced. And then you execute it, and then I'm using this data frame X here to execute my model. And X could could also be a standard data set, or it could be a runtime given data set. It strongly depends. Then I put a little bit of naming to my new posteriori probabilities. And what's the output of my score data? So it's basically these two new columns. So it's the probability for the 0 event, because it's a classification model, and the 1 event. The rest down here are the predictors, which are used for scoring. Yeah. And the first, normally in this step, you wouldn't see the first column, because that's the actual. So what really happened in the system? Somebody in this in this case, it's credit default. Somebody defaulted his loan. But that's how you collect data. So you score the data once it's published. You use your model for execution, and you can see what really happened. And then you can do the comparison. And the next step is basically doing what the RS call a performance task execution, where you would like to see how your model is degrading over time, because you usually collect the difference of prediction versus actual over time, monthly, weekly, quarterly, whatever where your business makes sense. So here we are executing this task. A step I dropped here to make a little bit thinner is you usually define performance task before. And defining a performance task is nothing more than saying, when do I want to have an alert or warning at a certain degradation level? So that's what we see in this call as well. So I define that in an extra REST call when I want to trigger the retraining automatically, essentially. So, and here as well, you see, I'm talking to my service, to the model management API, and the path is the performance task, and I give it the performance task ID, I produced before by a REST call. As I said, it's simply defining thresholds. And what the JSON object which comes back, and sorry for not printing it here, is basically SAS code which the system produced and gives to our core. And if you look down here, it looks weird, but it's pretty so it puts, I can get it on one slide easier. But for instance, here you see something like lift 5 decay greater than 0.15, saying, so if your cumulative lift on the 5% percentile is degrading by more than 0.15, and on the 10% percentile decaying by 0.12, you'd retrain. So that's the trigger, and it's here in this code. So it's documented in the return object of the call. So the good news again, you can double check on the graphical user interface what happens. As I said, I'm just showing the GUI to show you what really happens. But of course, in coding, you really don't need it. You can completely automate that. And so now, because I'm writing everything to the central repository, the GUI grabs the information up and showing me all the necessary reports. And it's showing me on the left upper side the degradation over different quarters of the cumulative lift. One potential performance measure, you can have others. So, and that's the reason why the system would automatically now trigger, because I set these thresholds, would trigger the retrain. So retrain then so what it would do, of course, it would require the retrain code we had at the beginning as well. In the first step, for retraining, I of course have to know where my retrain data are. So in this case, I just put them on disk. But as I said, it could be you can define that on different levels, on the model level, or you can define that on the project level or at runtime, whatever you like. And then I'm just giving fancy names to the variables here, doing some imputation and basically split into training and test data to have a minimal robust model. That's the minimum I should do. You should do more, a little bit more. The next step, something I drop is reading the pickle object, refitting the model, and then measuring accuracy. Yeah, and the last step, I then serialize again my retrained model so that I can give it a new version in my repository and import it into my repository. And these are basically the last two steps. This steps here is essentially I'm talking to the repository API now, to the projects. I know my project ID all the time, and I increase the version of the model. So that's just increase it by 1. And the next one, that's the guy you know from the beginning. Just register the retrained model to the repository again for doing all the fancy stuff we saw so far. So that's now it has a new name, but it has also a new ID. So that's basically clothing this automized loop. As I said, everything you saw from the graphical front end is just nice to have. It's not a must, of course. So here again, you then see how it's in the repository for the project, has a new name, and has a new version number. So we incremented the version number. So I think what we've seen so far is that we can use Python and the REST paradigm to automate the life cycle. But I think we also saw that way probably is not the most standardized and most reusable way, because you merge the application logic, the data, and the workflow logic. So this graph you are essentially executing. And that's in the last part, what we want to do is separate this workflow logic from the rest and go from there. So if you look, and I have to, for that, I would like to explain the workflow manager and what it's essentially doing. So if you look at this automation, this cycle of model lifecycle management, which can be much more complex, but it's essentially a graph of service tasks. And sometimes, as less as possible, you have an interaction with the user. For instance, if somebody has to approve the operational model because he's the one who gets killed if things went wrong. So that happens, unfortunately, both. Not that somebody get killed, but he get punished if it's too hard. So, That's a user task. So we essentially have service task, user task, we have a graph, we have some routing logics. So that's essentially what computer scientists would term a business process workflow. And business process workflows usually get modeled in a graphical way using business process model notation. So it's a graphical modeling language. And that's essentially what we offer with Workflow Manager. It's a graphical workflow engine. So you can design the workflows, you can save them in a repository, and you can execute them. So there's an execution machine behind that. So we are basically, what are the basic ingredients we can model? So user task, as I said. User task means a prompting framework pops up and asks the user for certain input. Service task like a mail or calling a web service. And then, of course, everything related to structuring the graph, so sub-processes and call activities of other workflows. And finally, what makes up the whole workflow is it's the gateways, the routing logic, the timers, and the tool also has complete language localization. So that's basically what the Workflow Manager is doing. It's giving us a vehicle for the standardized workflows, so we can now separate the logic. One word, so if you go into production, so if you want to use workflows in certain clients, like this model management software or in the risk software we have, so it's basically workflow engine, nothing more. So it's the first thing is this engine, of course, writes and reads XML because that's the standard. And once we read in the XML information, we saving it to our own file system, versioning it there. And whenever you want to use a version of a workflow, you have to enable it. That means you're just blocking it, because you shouldn't be able to change a running workflow. And runs means that you're instantiating for your client and for your project the workflow. And so it's important that nobody under the hood starts modifying this workflow. Of course, you can take the version, upgrade the version number, and go from there, and then enable it for another task. So what happens now when the client, which is the model manager, and the workflow manager software interact? So first of all, this is a screenshot from and again, you can REST code that and completely go over APIs, but essentially this is the view in a certain project, which is called QSHMEQ. So that's my model lifecycle management project. The administrator has a workflow tab where he can see which are the workflows in the repository I could use for this project. So he could use different. There's a whole repository of that. And then he activates, he starts that. He has the right to start the workflow and therefore instantiate it for this project. So then the workflow engine triggers everything which is in the graph, so all the service tasks. And only if there's a user interaction, the corresponding user gets in his workflow queue, gets the task. So there might be several people who get the same task, and the first person who claims it has the right to do it. And if he unclaims it, the workflow goes on. So that's the basic interaction on the project, on the model managing side. On the workflow side, you can look at any time in any project, in any instance where the current state is. So it's a sort of status and testing tool also to double check that your workflows work right, are used in the right way. And of course that over hundreds of workflows and thousands of projects, if you like. So going back to the main task, and that's basically my last slide. So how would we now bring our Python code into the workflow? So separate the logic and make it more standardizable, and again, make the regulator happy. If a regulator sees tools which are workflows and which are event tracked and all that stuff, they get really happy. So so here you see on the left-hand side, it's a workflow tool where we have the registering task. I think you probably know, you can't read it, but essentially I'm splitting the registering task into 3 subtasks. A user action which imports important information, and then I have 2 service tasks. The first one is getting the project ID, and this last one is really doing the registering. So looking to the code, so for the first step, the user interaction, and again, that's just to show you the idea. Usually you would do the naming, and what I'm doing here, you would automate that. But just to give you the idea, you need the information where the zip file of your model is lying, or wherever it's lying, and you have to give the model a name. So, and that's what happened in the code on the right-hand side. Here you would get this information from a user interaction, so a prompting framework, and the user would type in the two information. So not a must, just an idea to explain the idea here. And the next thing, we need the information about to which project we would like to register the model. So, in this case, we know the workflow tool is knowing its context, it's knowing its project, its instance, so we can get the information via REST call. That's something I don't show here for time reasons. But the last thing is, now we have essentially all information available to do the final call. So that's the post call here on the right side. Yeah. And we put that in here in the tool. That's the REST call. And it's the same you saw before. It's the repository, the model, the name of the model, the zip type, the project ID, and give it just the usual version number. So that's one point. And the last point, we have to fill the body of the call. That's basically the information which is split here over the code. So where we open the zip file, we define the files structure here and give it over the body of the REST call, and we put that down here in this mask. So now you have really a standardized way of doing model lifecycle management with predefined workflows which are fully separated from the application logic and the data. And that's basically my last slide. Just to give you some ideas, probably I was a little bit too programming centric. I didn't show you the complete Jupyter notebook. As you saw, it was a Jupyter notebook most of the time. But we have lots of stuff on GitHub out there, so about how you connect to the platform. So everything is out there, fancy examples. We, of course, have a full documentation, not only of the REST API going to our engine, but also the Java, the Lua, Python, and R interfaces, everything fully open documented. And there's a little bit further reading. I'm not sure about this. It's my first time at this conference, so I think you will get some information later on, so you can look up all the information. And that's basically it from my side. And yeah, I'm not sure how much time we have, but I'm open for some questions and remarks, of course.
Okay, thank you very much, Martin, for the interesting talk. Do we have questions already? Right. Maybe something that I saw in your abstract. You were talking about how you have tools to improve collaboration between multiple people working on the same models. I know the focus of the talk was really not on that, but you teasered it a little bit in the abstract. Yeah. Could you talk a little bit about this, maybe? Yeah,
I think the main idea is giving, so there are different things. As I said, if you do the model lifecycle management, the repository is the main collaboration tool. Since everything we do goes to the same parallelized compute core, so it really doesn't matter which paradigm you use to code to our code to our core. So, for instance, if you take a Python model, we under the hood can immediately lifecycle manage it. And people can cooperate in this way. Of course, we have cooperation in the sense that different roles have essentially all the same HTML5 interfaces. They talk to the same code. The business analyst talks to the data scientist, for instance, on an explorative tool. So just by dragging and dropping. But the outcome is a piece of code because these two modeled interactively, and this code can directly be integrated for the data scientist in the next phase, either by visual modeling or by integrating this into a code segment. So it's more that everything is one platform, one compute core, one HTML5 graphical user interface technology. Yeah, and people just can throw snippets around and you can consume them in other parts. So, of course, there are central metadata repositories where you can put that too and people can grab up the information.
Right. Thank you very much. Yeah. More questions? Then let's give another round of applause for the talk.